We are, sorry about that. We are just waiting for a few more people to join and then we will start. So give us just 2 minutes and then we will be good. Okay, nearly there. Just checking that everyone can see us online. Nearly there. There you go, we are good. Everyone can see us online. Okay, hi everyone, welcome to this Valentine's Day webinar. I'm excited that it's Valentine's Day and we get to spend it with you. So this webinar is all about obviously Qt6 and how to successfully migrate and upgrade your device. And I am Georgie Ryan Casling, so I am the content manager for Witekio, and obviously today we are running this webinar in partnership with Qt. So first of all, hi if you're watching on Livestorm, if you're watching on YouTube, on LinkedIn or on Facebook or any other platform that we're live streaming this on, you can still ask your questions, please do. They will be answered at the end. If you're on Livestorm, there is a questions box down here, and on any other platform, just ask on the live box and I will be able to see them and we can ask them to our experts at the end. So let's get started. So first of all, this is a rough outline and agenda of what's going to happen today. So Witekio will start covering things about why migrate to Qt6, how to migrate to Qt6, and the supported tools that can help you do that. And then Qt will take over with a Qt introduction, a framework roadmap, and there's also a demo from both Witekio and Qt, which is really great to see things in real life and in action, which is what we're here to learn. So I'm going to hand you over first to Vladimir and then to Karim, who will kick off the presentation. So thank you.
Yeah. Hello, everybody. My name is Karim Atiki, and I'm working at Witekio as a technical leader and also software developer for embedded systems. So I've joined Witekio for about 6 months right now, and I've been mostly working for embedded software companies. And for example, like PGA Electronic, which is specialized into aeronautics. So it's a great pleasure to work in Witekio and still working with Qt framework.
Okay, and I'm Vladimir. I have quite some history with Qt. Actually, I started working with Qt in 2006. It was Trolltech that time. And after this, I also worked in a few other companies. So basically learned the ecosystem from all possible sides. And today I'm working in Qt company. I'm a part of the team of technical product management, and I take care of, we call it Qt Foundations. It is a collective name for quite a few areas. So basically it is almost everything which is non-UI, but does include QML. So it includes Qt Core, Qt for Python, Web Engine, and a few other projects. Some of them I will also mention later. And I will hand over to Karim.
Okay, so let's start the presentation. Oh, okay. Migrating to Qt6. First of all, it's a pleasure for me to talk about Qt in this webinar, as my own experience is really tied with Qt. I've been working with Qt framework for about 22 years, back to the version 2.0. And indeed, Qt's evolutions has never ceased to impress me. Nevertheless, we're not going to talk about Qt 2.0, but Qt6, and precisely how to successfully migrate to Qt6. I'll try to provide just some guideline and technical advices and suggestions to help you in this task. In the agenda, we'll discuss the following topics. Firstly, why migrating to Qt6, and technically how to migrate to Qt6. And finally, we'll close my presentation with a quick demo of a supported tool named Qmake to CMake to help you to migrate your project file to Qt6. Why migrating to Qt6? Many developers and even project managers often want to know exactly why should we migrate a project to Qt6. The first point concerns the improved overall QML performances, which are rarely appreciated on some embedded hardware. These performances are also tied with the full universal graphics architecture provided by Qt6 within the rendering hardware interface. That was already but partially implemented in the latest Qt5 versions. Now, today, the graphic performances no longer relies only on OpenGL, as you can see on the graphics. Many boards now fully support Vulkan libraries nowadays, or Metal for macOS, or even DirectX for Windows. So it was normal that Qt could take benefit of them. Bindings are now available in the Qt C++ API, allowing the developers to leverage bindings features in their C++ business logic. This is really a great improvement, as the business logic code is likely much faster in the C++ side. Another point concerns the enhancement of the C++ API of Qt and the support of C++ 17. That was very expected by the C++ community developers who aim to write modern C++. And as the latest C++ versions are changing our way to program, it was logical that Qt follows the same path. Finally, the internal meta-type engine and the related covariance layers have been internally restructured with respect of C++ 17 features. Also, few points to consider. Qt6 indeed requires C++ 17. Today, it's a good opportunity for the developer for writing modern C++ and even look forward to C++ 20 features. But it also means that the toolchains require recent compiler, such as GCC 9, Microsoft Visual C++, 2019, etc. So if you are working on a specific board hardware, please be sure that your BSP does support recent library. Sometimes it's not that easy, and you may have to update your BSP layers. Secondly, this is, however, obvious, but do you really need to move to Qt6? Just ask yourself the question, is your application stable in production? At the end of its life cycle, no new features are anticipated. Always consider the time you could spend on the migration and its related return on investment. But, however, if you're in the main process of development of your application, if you want to take advantage of modern C++ with Qt, then you should really definitely consider migrating to Qt6. But how to migrate to Qt6? You'll find below a quick guideline. If you're already programming with Qt5, it might be a good step to firstly move to Qt5 15 LTS in order to prepare the final step. Then we'll also cover the Qt5Compat Module. And migration will also be successful if your unit test succeed. And finally, we'll have a look to how to port your code to Qt6. Porting to Qt5 15 LTS shall be considered as a good interim step before moving to Qt6 for several reasons. First of all, it is the opportunity to get rid of features and classes that are already deprecated in Qt 5.15. Keep in mind that deprecated classes and functions will no longer compile in Qt 6, and you'll find yourself with a lot of code not compiling. You can modify your project file as described with the following instruction so that every deprecated classes and function will be highlighted in Qt Creator. That will help you to modify them. Once your code is clean with the deprecated features, the next big thing to consider is a build system. And from my point of view, it's a great step to achieve that shall not be underestimated. Every Qt 5 user has already at least one time recompiled Qt with specific module using Qmake. And also Qt 5 already supports CMake. Its official build system is still Qmake. In Qt 6, the official build system is now CMake, and even if Qmake is still supported, it is strongly recommended to convert your Qmake project to CMake. But we'll cover this part a bit later. If your Qt 5 projects already use CMake, however, be careful to use the versionless functions of CMake. For example, using Qt add big resources instead of Qt 5 add big resources, Qt wrap CPP instead of Qt 5 wrap CPP. It's a very simple modification that will make your CMake project compatible with Qt 6. Once you finish with Qt 5.15 LTS, just keep in mind that the LTS ends by the end of May, by the end of the month of May of this year. So it's not a long-term solution. So let's jump into Qt 6. Porting to Qt 6. Once your project is correctly working under Qt 5.15 and your project file are converted to CMake, it's now time to get it compiling with Qt 6. Firstly, you must be aware of some important changes in Qt 6 regarding the containers, QVector and QList. I think that these two classes, along with QString, are by far the most used in Qt library. QList and QVector are surely used everywhere in your code. That's why particular care must be taken with the two classes. The good news is that QVector and QList now share the same implementation and memory management. Now the QList now behave much like a QVector class. Accessing the elements is way more faster. However, keep in mind that if you are using iterators to go through the containers, they now get invalidated if the container size changes during the iteration loop. So don't forget to update the iterator after inserting or removing the elements, as shown in the code snippet. If your legacy Qt 5.15 code uses them, you'd better proceed to a serious code review, as it could lead to unexpected behaviors or even crashes. One alternative is to use more often the standard template libraries, such as vector and list, unless you need to expose your list to the QML side. Note that the same issue occurs with the QHash and QMultihash classes. In that case, you can consider refactor your code using the standard map or the standard unordered map. The Qt5Compat module. That's a great thing that Qt 6 brings up. It introduces the Qt5Compat module. Indeed, in Qt 6, some classes have been definitely removed, but they are fortunately replaced by equivalent classes with sometimes method names very close. It's a module that you need to link to specifically so that it allows you to keep using the classes normally removed from Qt 6. In the first time, if you need to perform first-line tests with your application with Qt 6 and ensure that it's globally working, the Qt5Compat modules appears to be a valuable question. But as migrating to Qt 5.15 LTS, the use of Qt5Compat module shall be considered as an intermediate step. I strongly advise against using Qt5Compat as a long-term solution. Among the concerned classes, the XML SAX parser is now replaced with the QXML stream reader and QXML stream writer classes. These two classes are very convenient to use, and the effort to migrate to them should not be too important. So you no longer have to create QSample reader, QXML inputs, implement handlers for the content and the attributes. I think that the QXML stream reader and QXML stream writer are very easy to implement and very easy to test in your unit test, which is not always the case with the SAX classes. The QLikenList object no longer exists. If you still need it, replace it with a standard list, class list. If you just need to have a list to store pointers to object. QStringRef is now replaced with QStringView, or even the STL version of the class, the standard string view. Finally, the QRegEx class is replaced with QRegular expression. Check out the method names that are very close. The two classes, it's very easy to use a QRegular expression. The only difference is that there is a match object created as soon as you have matched an expression. And the method name are replaced by capture count, capture length, and cap with capture. So it's a transition, it's a conversion process. It's very easy to put in place. Unit test and regression. I'm sure you are serious developers, and I hope your application already provides robust unit test along with a CI/CD environment. If it's not the case, it's never too late to write unit test. Keep in mind. As you may have modified and refactored your application's code, you will surely have to review your unit test, particularly regarding the part of the code that use new classes described above. If your business logic is massively using QList and QVector containers, don't hesitate to add new robust unit test. Indeed, the goal is not to only have code compiling without errors, but to keep the business logic functional. Finally, put in place integration tests to troubleshoot the graphic user interface, especially if you have written QML pages. As I said before, OpenGL is no longer the default graphics backend. If you absolutely need to use OpenGL for specific hardware or any other reason, you will need to specify it manually with setting, for example, the QHG underscore RHI underscore backend environment variable. Depending on the board your application is running on, different backends may be used by default, such as Vulkan, Metal on macOS, or Direct3D for Windows platforms. Ensure yourself that your graphic user interface and elements do behave as before. The more time you spend testing, the less you spend debugging. Migrating a QMake project to CMake. As I mentioned it before, converting a QMake project to CMake might be complex sometimes. One reason is that some features of QMake are not always well documented, and every feature is not exist by default in CMake because these are two different build systems. And also you can write the CMake file from scratch. There are today some existing applications and scripts written to help you to port your project file to CMake. QMake to CMake is one of them. It's a simple Python package that you can install from the PyPI repository. You can install it by just running the command pip install qmake to CMake from your terminal window. What does it do? Basically, Qmake to CMake create a CMake list file that covers the most common attributes of your converted Qmake project file. The resulting CMake project shall be used as a baseline, but it will most likely need manual adjustments because Qmake features that could not be converted will end up in the CMake project file as a comment. And these comments are really helpful when converting these manually a bit later. However, some features are not supported by Qmake to CMake. The template declaration of auxiliary project is not supported. The custom features file are not supported. And be careful because some legacy Qmake projects heavily use them. The extra compiler support is not supported, as well as the extra target. Okay, how does it work? Let's make a quick demo with a very simple project with the subdir project. It means a very simple QML application and a depending static library that exposes a QObject-based model for the QML side. I will share my screen to make the demo with Qt Creator. Okay. Sorry. Okay. Here we have the main Qmake project file with a subdir declaration. In the subdir, we can find the final QML application and a static library that exposes a QObject. Okay. Every subdirectory, every subproject has its own Qmake project file, as usual, with some declaration for linking the project, some default rules for deployment, etc., include path. So it's very straightforward project. Nothing is complicated. Sources, headers. Okay. It's a very simple example with a wonderful Hello World application and a QML page to display a picture background. Okay. Now we will convert this project to CMake. Okay. Oh, fine. For this purpose, I'm using Qmake to CMake script, and specifically Qmake to CMake _all, which is a variant of the applications. I'm using Qmake to CMake all because they are subdirectory with subproject. So instead of calling Qmake to CMake for every subproject file, I'm using Qmake to CMake all to process the whole project tree. I just have to specify the main project file and the minimum Qt version the application must be built against, because by specifying the minimum Qt version, it will select the related CMake API. So it's very important to specify it. Now I'm just running the script. It's pretty fast. And we can see that every file has been converted, the 3 files. Okay. Right now, I will close the Qmake project and open the CMake list, the main CMake list file. Okay. The project is getting loaded. Fine. Okay. I can find my project tree and the created CMake list file. So the main project.pro file has been converted to the main CMake list with the version of the CMake API used and the version of Qt used and the selected components, Qt Core, Qt GUI, Qt Quick. And finally, the 2 subdirectory to include the subdirectory CMake list file. Okay. For the static library, and for the QML application, including the directory of the static library, the source file, the resource file, and the deployment instruction. There is just one manual adjustment to specify in the applib, because it seems that the static keyword has not been included during the conversion. And if static is not specifically entered, the library is considered as a dynamic library. So when it's done, execute CMake. Okay, good. Let's compile the project. Seems to be good. So we have the same result. we still have our wonderful Hello World application. Okay. I will stop the sharing. Sorry. Okay. So also this project is very simple. You can just notice that the conversion is very straightforward, and it's very helpful to have, the project architecture skeleton put in place with a conversion tool. But of course, manual adjustment will be needed, maybe by writing shell script or Python script around it. But the main conversion is very interesting. It saves us a lot of time. We're talking about time, and unfortunately, we're running out of time. So I will let now Vladimir speak about Qt. I hope that this presentation has convinced you, or at least comforts you in the idea of migrating to Qt 6. If you have any question, don't hesitate to ask. Thank you so much. Vladimir, it's your turn.
Okay, thank you. In my presentation, I will talk about 3 topics. So first, we'll give you an overview of Qt as a product. I will also mention a few focus points, which we currently have as a guidance in our work in my domain, which is Qt framework itself. And I will also show a demo of pretty cool feature which we introduced in technology preview in Qt 6.4 actually. And speaking of the Qt or Qt products, many of us, and I do so as well, speak of Qt. We also say Q or Qt, just 2 words. But in fact, today, Qt is a multi-product company, or the Qt company is a multi-product company. There are other products which belong to portfolio. And we also split, for example, you can see on the screenshot, there is a Qt framework on the top, but Qt Creator, for example, which always was kind of belonging to installation of Qt, it actually listed as a development part of the development tools. But we also have some other products on the line, and the newest of those is the Qt Insight. This is a set of tools and also runtime for application where you can record and analyze user actions on your device remotely, and also make some conclusions. Was one of the examples. And we are also working with some other products which will be listed later, but we also got some other product lines which are totally different, and some of their customers actually do not use Qt. For example, Squish or Coco, there's a set of quality assurance tools which we acquired via the acquisition of the FrogLogic company. Speaking of the Qt framework, maybe for some of those who are not so familiar with Qt, I also got here a few highlights about Qt, what I also personally like a lot. Qt, first of all, it is a full stack framework. And so it basically provides you all tools and APIs for the whole range of development of an application. So from the backend to the UI, but we also provide APIs certainly for talking to the network and doing some new things. But we also provide extensions which go beyond the application development itself. We are also cross-platform, and I actually recently added to the slides inherently cross-platform by this. So this is because you don't need anything being for cross-platform on top. So Qt provides these tools and they are transparent for you. So you don't need to install any additional component which let your application run on, say, Windows. Those platforms which we list as supported, we do support them out of the box. Qt is also running natively. It compiles on your machine, or you can certainly cross-compile it for embedded and execute it natively. So we also have certainly QML with the QML engine runtime. But even this component today is capable to generate C++ code and compile it in a runtime of your app. So even QML applications run partially as C++ applications natively. Another interesting aspect, as one side of it, many of you maybe know, Qt framework, Qt itself is an open source project as well. So at least most of components in my domains, they are developed in open source. And what is interesting for customers as well and for users, Qt is a source code product. So you will get the source code from the first byte to the last as a part of the delivery. And for some industries, some customers, it's actually an important point. It is also self-contained. What does it mean self-contained? So if you get Qt and use Qt, you get it as a toolbox along with the tools, but you don't get, say, yet another project you need to take care of. You once install it and use it. So you don't need to kind of install this and this to get this finally working for you. Again, this is out there when you install it. And we also multi-language meanwhile. So Qt started as a C++ framework, but today, for example, we support Python. We provide bindings for Python and the whole package called Qt5Python. Some of you might know it as PySide 2 and PySide 6. 2 was 5. There's a special history why it's 2 and not 5, but again, set of bindings, and Qt4Python also provides some other elements or tools around it, making it a complete offering. Another point what you should not forget in your projects is Qt as in the market is more than 25 years in the industry, and it is used by some very, very prominent parties. So it is accumulated experience of those users, plus the works of development in the Qt company, as well as in open source, fixing and improving, fixing bugs. Yes, there were bugs, there are always bugs in place, and we do fix them, so we care. And this is a large improvement over the quality of over time in those specific APIs. But we also add some new components, so many things are totally new and also have been added in last years. So we never stop developing it and extending it. And at the end, I have a quote from a customer, from the developer, and very proud that people actually keep saying this. It's not the only one quote. So people actually like it. So people come to their colleagues or their manager and say, hey, cool, I like it. It's fun. Coding is fun again. And I'm very proud about it. And a lot of people also proud of it, that people say so. And we focus our works to make it going this way and also apply this pattern to anything what we do as a new component extension to Qt. Speaking of releases, we do have a certain cycle. Qt usually Qt releases, sorry, are split in major releases. So Qt 6 was a major release. It has quite a lot of impact to the users, but it also a chance for us and for Qt in general to bring some major changes in the framework and also do some incompatible changes which are required, as you might know, in your software as well, to fundamentally improve things or add new things. But we also have feature releases. So feature releases are this so-called first dot releases, so 6.2 or 6.5, which is will be released soon, is a feature release. And there are also bug fix releases. So also in this diagram, you see that 6.5, for example, is one of the LTS releases. LTS releases are also relatively new, and they provide a long-term support for each third release in the sequence. and you get this support for 3 years compared to the 1 year support of the standard release. What I also wanted to explain is how the product itself structured on commercial side. So as I said, it's dual licensed, and we also provide additional products on top of the standard Qt, which is on this picture on the bottom of the actually the whole picture. One of the colleagues who made this picture actually called this an onion ring, and I think this is a very good comparison because it shows this in kind of stacked order, and you get additional things on top if you go up in a product line. So we start in the baseline that is feature-wise the same Qt framework as you will get it in dual licensed mode, and we call it Qt Community Edition. But you will get this in commercial terms, and all products on the top, they add different features on top. So for example, Qt for device creation also includes some tools for development, embedded development, plus it also includes support for Qt, for the new Qt for MCU. And with my next slide, I wanted to talk a bit about a few things we actually currently work in this year, and I picked also for myself a few highlights of our focus. So first thing what we currently do in this year, we do more for onboarding and learning. So also to pick up and make it easier for new users and new developers to start with Qt. I said here do more because we actually did already in the past a lot of specific works, but also Qt is known for its documentation, which is pretty detailed and available online and offline. But we actually like to keep doing or focusing on this and add some additional components to this to make the start with Qt even easier. As next, I have a quote from one of the heads of the business lines we have for desktop and mobile development. We want to focus on high-performing desktop applications, and also enable expansion to mobile and web in easy way. So it doesn't mean that we will do less, say, on embedded, but for the works we do on top of the regular improvements and expanding Qt, we wanted to focus in this domain. So, and the demo I will show later is one of the things we added to Qt also to enable some specific scenarios, and I will explain it later. Another project, and this is one of the project or initiatives which I run, is Connected First. So we call it Connected First internally because it consists of many other topics. One of the things we wanted to improve as first is using Qt with REST or RESTful APIs. It's certainly possible to use Qt with RESTful APIs, and many applications, maybe one of your applications also using this, but it involves quite some additional code writing. And as you learned before, we don't like it. So you should write your code and not any boilerplate code. So our mission here is to improve and simplify the use of Qt with scenarios where you need to use REST calls, so talk to a server endpoint. And the same thing what we currently do, we will be introducing this in Qt 6.5, is the integration of gRPC and protocol buffers. So I use gRPC as a name, but it certainly will include protocol buffers. So the whole package will integrate it entirely in Qt, so you'll be basically be able to use it with standard tools. I mean, standard in the sense that it will be part of your build process, the generation of the files from protocol buffers, as well as help us to set it up in your application scenario. We also did a few things on desktop and specifically on iOS. I'm also the product manager for the Apple platforms. On iOS, we integrated now a new style, which is, we call it PixMap-based style, but it mimics almost perfectly the native style on actual native iOS applications. So with Qt, you will get almost completely integrated from the look and feel perspective style for Qt applications. It will be the same as native iOS applications as well. And I also mentioned this before as a new product, Qt Insight. It's one of the products you actually can try yourself on the website. There's a link. You can start a trial period and see how it works for your application. What we also do, and this will be the part of my demo just in a moment, we want to support in the future or better support and simplify also the development of different hybrid, we call it hybrid scenarios, where you need to mix certain forms of UIs. So imagine you do an embedded device, and this is a concrete example from one of the customers. They provide a device where you have a need for remote maintenance. So certainly you can set it up in certain system environment where you add specific software to it. But again, our mentality and way of thinking, create more codeless. So for this, and this is where I will start with a demo. Okay, I think it's the next slide, sorry. I will start with a demo. So I think my screen is shared. The component which I like to talk about is, we call it Qt VNC server. And this application shows a very simple QML Qt Quick application. It consists basically of the window. There's a rectangle and a label. Maybe just instead of speaking, I'll just run it. So it is a certain chat application. So in the middle, in the black screen, there's some text area. You can write some text. So the special point about this application is the new VNC item, which embraces this black rectangle with the text in the middle. So with this item, everything which it is embracing, and this also includes entire application, and it's also compatible with Wayland, Qt Wayland module, so you can use it also to implement a compositor which will able to share specific application, not only a part of one application, but the entire application, the entire screen as well. So everything which is embraced here becomes a surface for VNC. And here I will actually have it running here. It is just a standard VNC viewer. So if you start a connection, it brings a warning about encryption, and there are some, in the docs, there are some explanation why it comes and actually what it means and how you can use it. So, and what you can see here, let me get the actual app on the screen as well. So what you see here is the mirror of your typing. And this is not only in one direction, it's also actually in second direction too. So you can go here and start typing something here. So, and it also multiplexing. So you can connect as many clients as you like. There are also some additional features. You can add a pin for simple protection. You can also add some indication if the client is connected, and then this is implemented in this example. So if now the circumventing rectangle is green, so if I stop my viewer, it becomes red. So it basically tells, okay, the client is gone and you are now basically not sharing it anymore, but the application will still work. All self-contained, you don't install anything. So it is a part of the module. So certainly you can write, you can start the VNC server underneath the application itself. But it is something what you need to do. And what this customer, which I mentioned before, with the remote maintenance, they do have a certain system which in place, and they want to have an environment where they can just enable remote maintenance if the operator of this system don't know what to do or something very strange happened, so he needs help. Yeah, this is my demo. And I think now we go to back to the slide, which I kind of in a sneak mode showed before. I will just scroll to it, and I will handle over back to moderators.
Thank you so much. Thank you, guys. That was amazing. Just very quickly before we head on to the questions. So I just want to highlight this because obviously Witekio and Qt, we have been partners for a long time, which we're happy with. We actually, last year at Embedded World, celebrated 7 years of partnership. We've completed over 50 projects together in a host of industries, from medical to vending machines to all different types of things. And also on our website, if you go onto Witekio or Qt and you type in on Witekio, you type in Qt, or Qt, you type in Witekio, some of these resources will come up. So there's other webinars that we've done with Qt, as well as some videos showcasing our collaboration in trade shows and different demos that we have. So don't think that this is just it. If you want to know more about both Qt and Witekio and our partnership together, there is plenty out there. So yes, so thank you, speakers. Thank you again. Thank you for all your demos. And now we will go to questions. I have some that have been sent by email. If anybody has any questions in Livestorm or online, obviously just ask in the questions chat or in the chat button, and we'll be able to answer them straight away. But let's get started with the ones that came in first, because I think that's the fairest way to do it. So one of the first questions is talking about licensing options in general. So obviously, Vladimir, I think you went over the kind of the different categories that Qt have, but is there anything you can add about licensing options?
Licensing options, again, that scales. So it is dual license project. You start, or many people also start this in the school or learning it. So with open source licensing, so it is a mix of LGPL and GPL version 3. And then you go for a commercial option. Certainly, you need to comply with the obligations connected to these license terms. If you decide for commercial licensing, then you will get a Qt framework under commercial license. And then with all other steps up in the product line, you will get additional functionality. I mentioned, I think, compilation of the QML before, what we provide. So the enterprise package of Qt for application development includes, for example, extensions for the Qt compiler, which provide additional functionality and some additional acceleration of the code which was generated.
Okay. Karim, do we need to add anything on the kind of the software side, or does that cover everything?
Sorry, I didn't get acoustically. I'm sorry.
Perfect. Okay, moving on. So another thing is asking about backend support. So he's saying that the person whose question has said that they've last built it with, and excuse me if I'm saying this wrong, eGIFs. He spelled it EGIFS, and support. Yeah. So support a year or so ago. So is there any backend support that people can have if they do decide to build with Qt, and what is it that we can do?
EGL, or maybe Karim, do you want to explain?
Well, please continue.
So for us, it is seen, we call it QPA. QPA is also a plugin. This is called for Qt Platform Abstraction. So currently, we abstract this. We introduced a new layer, which Karim mentioned on the slides. It is called QRHI, so it's hardware abstraction layer. And this layer supports also the backends which we had in the past, or say supported in the past, but it's now abstracted by a new additional layer. So we can work natively on desktop platforms, let it be on Metal, Vulkan, and also on Windows platforms. And GLFS is embedded platform. This stands for Embedded GL Full Screen. It has certain specifics and certain additional options for embedded devices which you can use. But we do support this as well. And we also support specific QPAs for embedded systems. For example, we support QNX. QNX has its own QPA, or VxWorks. So I hope the question was about the graphical backends.
Yeah.
I think so, by the nodding and the thumbs up that happened. So we're good. Also, we've had a question asking if there's more joined up support for Yocto/ST Open Linux builds. What I think by joined up they mean is, you know, they've got ST Open Linux build and they want to, or you know, Yocto/ST Open Linux build and they want to put Qt on it. Do you have a kind of support for that? Or if not, maybe Karim, this is a good place to talk about how Witekio could help with that.
I think that Qt already supports, has already Yocto supports. In the different licensing terms, I guess there is Qt for embedded software. Okay, it's a special package, and Qt provides a lot of layers that support many boards, Toradex board, Raspberry Pi, many of them. And the whole system is built around boot to Qt. Okay, it's a Qt system and designed around different Yocto layers to have a complete system working for a specific hardware board. Okay, so that's very easy to put in place, and the Yocto created image provides the whole Qt framework deployed on a specific Linux image. So the developers just have to integrate their project into this layer to have it built and working on the target board. If you are not using boot to Qt, you can always have Qt5 or Qt6 compiling into your Yocto project by including the necessary layers into your project. So it's very easy to get it compiled and to get it work on the target board. So many things already exist into Yocto.
Perfect. Another question about multi-monitor support. So I don't know, Vladimir, if you've already covered this, but about, is there any multi-monitor support?
Yes, so on desktop, so usually the multi-monitor support, the monitors and screens are managed by certain platform-specific software component. So in all the X11 times, it was called Window Manager. So Mac OS, Windows, they have different components. Usually they're actually not visible for the end user. The user doesn't know of their existence, but they manage the location of the windows on the screen. So for the application, it is transparent. So, and this is supposed to be this way. It is the part of the architecture. So on the desktop, you can click the mouse and move certainly a window to another monitor. It will be another screen. In a Qt application, you can query the location of your not only the geographical geometry of the top level window, but you can also query where the application is now currently located, and do some decisions in your application if it is on this monitor, that size. So this information is available to you. On embedded systems, so full screen, as we mentioned before, it is a GLFS is a full screen. You can configure, it is, by the way, generally supported, yes. It is also as much supported in Qt as your embedded environment supports multiple screens on the GLFS, and there's a documentation about this in Qt, how to use it with Qt. There are environment variables where you can specify on which of the multiple screens on your system the application will show up if you started from the command line. But you also can query the same way where the application is currently started, but also specify where the particular screen which you like to use if you open another window, so where this window should be started then. So this is available.
So yes, a big yes.
Yes.
A really big yes. Yes, you do. That's great. We've had another one asking for any tips or advice on the restructuring of the MetaType engine and Q variant.
Yes, it's a bit complicated to explain it fast on this subject because it's actually a big subject. Actually, the whole internal meta type has been restructured using the C++ 17 features. I mean, to take benefit of the C++ 17 features. The performance had generally improved, for example, by the use of the move constructors. That many C++ 11 developers already know them, and these features have been used inside the meta type engine to prevent from creating some override object. So during the creation to meta type object in Qt, taking benefit of these C++ features have drastically improved some performances. Okay, so you can find many detailed explanations on the Qt website. There are many resources talking about the subject technically. But the basic idea is to get benefit of the new C++ features translated into the Qt meta type engine, because every developer has already taken a look to the internal code of the meta type, the conversion of Q-based of object into Qt meta type engines, and it's not very easy. It's a very complex system that now is really leveraged by the new C++ features. That's the basic idea. Okay.
Okay. Anything to add, Vladimir?
No, thanks.
Too big a topic.
Complex topic. I think the advice to look up the documentation is good.
Yeah, of course. But it sounds like there's plenty of things on the Qt website, as you said, Karim. So there we go. And maybe actually we can go into that in another webinar. Who knows? We only have a couple of minutes left, so I'm going to leave it there. I'd like to thank our speakers. Thank you so much. And thank you everyone who's watching at home. I hope you have a lovely Valentine's Day. Wherever you are, whatever you're doing, treat yourself, treat everybody. That's what we want to do. And we will see you again. So thank you. Bye, guys.
Thank you, guys. Thanks for coming.
Thank you. Bye. Bye.
Bye.